We're going to take a static pressure reading on furnace. We already drilled our first hole right here. Now we're going to go drill our second hole. We're lucky enough to have a plenum on this guy. You can go right into it. Got our hole drilled here. Turn on our manometer. Make sure we're reading pressure, pascals. And then we'll insert our pitot tube in the direction of the flow. And we're getting a reading of 78, 74. Tape that up. Now the return. Woo! We're getting ready to 140 pascals. So if you convert that to inches of water column, it's probably going to be about 0.5, 0.6 inches of water column on this return here, which is super high. And that means that this return is either undersized, it's kinked, or there's some restriction in the airflow that's causing that static pressure to be so high. Put a little piece of tape on. The supply side looks good, but the return looks pretty high. They already have a plenum, so that's good. On a lot of these split systems, you don't even have a plenum on, and it's just a straight flex into the unit. We'll try to get the size off the flex, but looks like it's a 18 or a 20 inch. Makes a hard bend here. Maybe we can put 2 elbows off the return air can and 1 off the plenum. Try to ease that bend and add another return. And change, he's got some stamp face grills. I'd recommend changing those to a bar type to lower that static pressure. Once that's done, we'll come back and measure the static pressure, make sure it's been reduced and he's getting good airflow across the coil. Our supply side looks good. That static pressure looks fine, which means there's less restriction or no restriction in the ductwork. You can see they didn't do a great job sealing this thing up here. Just put some tape over these gaps. So the static pressure may be a little low just because of duct leakage. But I suspect even if we seal it up good, it's still going to be a pretty low number.